Oh, I believe it the live stream. I don't care. What if we go back? Let's watch myself. Oh man. Right. Okay. So I believe the audio is recording. So then let's begin. I believe it the live stream. Okay, sure. I don't care. Past me. Okay. Let me see if it's recording this. Poopy African. Just give it some time. So COVID. You're not a COVID. You COVID. Okay, good. It's recording. So let's begin, I suppose. Let's do timer 40 minutes. Okay. In 3, 2. Oh, let me bring up the Epico chat. Oh, got it. Okay, yeah, that's good. Right, Chief. Oh God, there we go. I believe this is how it's done. Oh my God. 3, 2, 1, go. Right. If you could not tell, today we are doing the 1990 AJHSME with your boy me. So let's begin. 3, 2, 1, go. Oh, let's go to OneNote. Can I scroll? Yes. Okay. No, not that far. Oh no. Okay, that's fine. I'll just remember my answers. What is the smallest sum of 2 3-digit numbers that can be attained by blah 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 blah? So if we think about this, right, if we want the smallest sum, then we want the smallest numbers to be in the hundredths digit, then the second smallest numbers to be in the 10th digit, and so forth. Smallest 2 numbers are 4 and 5, so let's put a 4 in this box and a 5 in this box. Next is 6 and 7. It doesn't matter how we orient it, it's going to be the same sum. And 8 and 9. That gets us 1047. Oopsie poopsie. Let's go to the next one. Which digit of 0.12345 when changed to 9 gets the largest number? Well, it's kind of like the first problem, you know, like you want to change the smallest, the largest number to a 9, right? Which is going to be 1, right? Because if you change a smaller number, then obviously you're going to get a smaller answer. So let's do 3. What fraction of the square is shaded? Well, let's see. So we have this guy, right? This small square, and in the square, half of it is clearly shaded. In this area, this L-shaped area, once again, it's cut in half. This large-shaped area, it is once again cut in half. So each of them are half, so there's no multiplying or anything that we have to do. E1/2. Which of the following could not be the 1st digit of a square of a whole number? Let's think. 1 can, right? 1 squared gets us 1. 4 can, 2 squared gets us 4. 5 can, because 5 squared gets us 25, which ends in 5. 6 can, because 36. 36, which is 6 squared, so then it's 8. Which of the following is closest to product 0.48? Oh, God. I might even get this one wrong. Okay. Let's go 48 over 100, which gets us 12 over 25. Times 12 over 25 times 12 over 25. Oh, God. 12 cubed over 25 cubed. That is, not funky. Okay, well, we can obviously eliminate these options. And we can eliminate this one, because 12 cubed is nowhere near 25 cubed. It's not even close, so it's going to be A. Which of the following numbers is the largest? Well, let's think. So you have this one. So far, this one's the largest, right? But then this one is smaller. This one is smaller because then you're dividing by it. But this one, you're multiplying, right? So I believe it is this one. So let's get out the eraser. So because this one you're adding, however, this one you're dividing by it. When you divide by a fraction, so x over 1 over y, it's the same thing as x times y. So then you're getting 13,579 times 2,468, which is the biggest. This one is obviously the same thing as, no, not the same thing, but it's much smaller. When 3 different numbers are multiplied from the set, that largest possible product is, oh boy, what are the largest 3 numbers? 5, 4, -1. But that gets us a negative number. If we multiply 2 negatives, then we'll get a bigger number. The smallest 2 negatives are -3 and -2, and then multiply those by 5, right? Because 2 negatives make a positive, but if you have 5, 4, and any of the other ones, then you're going to get a negative number. But 2 negatives and a positive will get us a positive number. Therefore, those are bigger. Therefore, you want the smallest negatives, or I guess the biggest negatives, depends on how you think of it. But the negatives that are farthest away from 0, and you want the largest positive, right? So -3 times -2 is 6, times 5 is 30. The dress was originally priced at $80, was put on sale for 25% off. If 10% tax was added to the sale price, then total selling price of the dress was, well, let's do this. $80, 25% off. 1/4 of 80 is 20. So we subtract 20 from 80, then we're at $60 plus 60 over 10. 60 over 10 is 6. 60 plus 6 is 66. All right. The grading scale shown is used at Jones Junior High. The 15 scores were that in Mr. Freeman's class, which percentage of students received a grade of C. There's 15 scores, right? So out of 15, how many received between 75 and 84? Well, it's this guy, this guy, this guy, this guy, this guy. I think that's all of them, right? Yes, it is. So 1, 2, 3, 4, 5. 5 out of 15 is 1/3, just 33 1/3%. Oh no, these didn't generate. Okay, that's fine. Let me actually write down the what you've got so far. Oh god. C A E E A A E E A C A E E A D C D D C D D D C D D. One more. Let's do this one then. On this monthly calendar, the date behind one of the letters is added to the date behind C. Wait, what? If this sum equals the sum of the dates behind A and B, then this letter is... What the heck? Excuse me? Oh. If the sum equals the sum of the dates behind... Well, I mean, we can just, assume that this is 1, the 1st, the 2nd, the 3rd, the 4th, the 5th, and Sunday the 6th, Monday the 7th, right? And then 8, 9, 10, 11, 12. The date behind one of the letters is added to the date behind C. All right, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? Okay. A plus B is 20. If this sum, so N, 3 plus N equals 17, which is P. So let's do in the notes A, right? So there's our thing saved. Now let's close this. No, let's not save our... Oh, we could just save our changes. Wait, nope. Never mind then. No saving changes. Let's continue on our way then, shall we? I think it's all generated, so we should be able to view all of them now. How much time do we have left anyways? Oh well, we have 30 minutes. Okay, it's all good, guys. Everything has generated. The numbers on the face of this cube are consecutive whole numbers. The sum of two numbers on each of the three pairs of opposite faces are equal. Sum of the 6 numbers on the cube is... Okay. Well, they're consecutive. The sums of... Oh god. Okay. That's... Alright, well, let's. Yes. Precisely. Let's think about this, shall we? What if, instead of 14, 15, and 11, we just subtract 10 from all of them, and then we'll just add 6 times 10 later on, right? So then we have a 4 on this side, a 5, and a 1, right? And we have this side is going to be 6, right? Because this is, then we just turn it into a standard die. And the bottom side is going to be 3, and this side is going to be 2. They're all consecutive, and it works. So we have 15, but then this is a 2, but then we had 10, so 12. So 15, 12, 14, 13, 11, 16. And those are all consecutive. Then we only need to add the pairs of integers that are opposite each other and multiply by 3. 15 plus 12 is 27 times 3 is 81. Problem 12. There are 24 4-digit numbers that use each of the digits blah blah exactly once. Listed in numerical order from smallest to largest, the number in the 17th position in the list is, oh boy. So we can really eliminate a lot. This shouldn't be too hard. I think I already know the answer. Okay. So what's the biggest number? 7542. That's the 24th, right? Now, once we start with 7, those are obviously going to be the biggest. There are 6 ways to arrange 5, 4, and 2, right, around, and those are all going to be bigger than something that starts with 5, right? So there are 6 ways to do that. So we're going to have 24 minus 6 to get 18 ways remaining. We want the 17th position, so that means that the smallest one that starts with 7, which is 7, 2, 4, 5, the next one will be 5, 7, 4, 2. And so this is going to be 5, 7, 4, 2, and then 5, 7, 2, 4, right? Is the next smallest number, which is going to be the 17th number, I think. Oh god, okay. Unless, you know what, we'll just skip over that one. I'll have time to check later on. Because I'm not sure if I've overcounted or something. It's either 5742 or 5724. Oh god. Because these can all be eliminated. So it's one of those two. Which is annoying. They couldn't have just given me an easier one. One proposal for new postage rates for a letter was 30 cents for the first ounce and 22 cents for each additional ounce. How many viewers do we have? Oh yeah. Anyways, this is less of a live stream and more of just me being lazy and kind of making it a video. Okay, 30 cents in the first ounce and 22 cents for each additional. For writing 4.5 ounces was, okay, well, 30 cents for the first ounce. So 30 plus how many is 3.5? Well, 1/2 is going to be 22 anyways, so 22 and then plus 3 more 22s is 88 plus 30, which is what? I want to do math. 118. A bag contains only blue and green balls. There are 6 blue balls. If the probability of drawing a blue ball at random 1/4 in the number of green balls in the bag. Well, okay, so that's 6 equals 1/4 x x equals 24. If we want, and that's the total number of balls, right? Then 24, we subtract 6, right? Because that's the number of blue balls. So we subtract 6 to get 18. The area of the figure is 100 centimeters. Its perimeter is, and it's 4 identical squares. So that means that if we call this side x, x, then these are all x, 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 and x. The area of one squared is x squared. There's 4 of them, so 4x squared equals 100. X squared equals 25. X equals 5, right? You divide by 4. X squared equals 25. Take square root. X equals 5. Right? How many x's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 x's. 5 times 10 is 50. Oh boy, this one's fun. Problem 16. Oh no. Okay. Let's do this. Okay. So it goes into minus 20 and then we're adding 10, right? So if you think about this, first let's think about how many terms are there. 10 to 1990, which is 1 up to 199. So there's 199 terms. If we subtract the 10 out to find how many terms are being subtracted, we get 198, right? And each of these are 10, 10, 10. But there's 198 over 2 that are being subtracted, which is 99. That gets us 990, and then we're adding another 10, so 1,000. That one was kind of a confusing explanation. You should probably look at the solution for that one. Okay, 3 feet long, 60 feet. 3 feet wide, 60 feet long, and 3 inches thick. How many cubic yards must a contractor order? Okay. 3 feet wide. Let's just turn it into yards, shall we? So 3 times 60 is 1 times 20, right? So that's 20 yards, and then times 1 over how much? 3 inches is 1/4 of a foot, which is 1/3 of a yard, so 1/12. 20 times a 12th, which is less than 2. So, and more than 1. So, each corner of a rectangular prism is cut off. 2 of the 8 cuts are shown. How many edges does the new figure have? Well, okay, well, this edge, I'm assuming it still remains, right? This one. So then you're adding 1, 2, 3 for each cut, I believe. Yes, you're adding 3 for each cut. There's 8 cuts. That's 24, plus the number of edges, which were already there, which is 12, is 36. I'm getting scared. Okay. 120 seats. How many? So that the next person is seated must sit next to someone. They're all in a row, right? So bam, 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 bam. Fewest number of seats. Well, it's obviously not 119, right? Well, let's think about this. You could have alternating, right? That works. Or you could have it in thirds, right? So this guy, but then you skip these 2 and this guy. Then if someone wants to sit within this corridor, then they have to sit either here or here, which is both next to him. So it's in thirds, right? Oh no, I don't like this. I'm going to overcount and then it's going to be disappointing. So let's think. Bam, 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 bam. 1, 2, 3. Okay. I'm trying to think here. So obviously you start with 1, then you have groups of 3, and within these groups of 3 you have 1, so that's 40. So if you have 40 people, then the next person must sit next 40. The annual incomes of 100 family range from $8,200 to $98,000. In error, the largest income enter in computer was at 980,000. Oh, jeez. That was the incorrect data and the mean of the actual data. Wait, what? Doesn't make... Oh. So obviously you added, what? 980 minus $98, which is what? I don't want to do math. 9, so 0, I'm 2, and then 8. 882,000. So you added 882,000, but then that's distributed between the 1,000 people as being mean by. Cancel, 882. That wasn't that bad. Okay. A list of 8 numbers is formed by beginning with the 2 given numbers. Each new number is a list as a product of 2 previous numbers. Find the first number if the last 3 are shown. Alright, so if this is 64, right? That means that it's also 16x. Therefore, x equals 4. So this is 4. Right? And you know that this is 4 and this is 16. So then 4x equals 16. So then this is also 4. Meaning this is 1. That means that of the 2 previous numbers. So then this is 4. Oh god. And then this is this 1? Okay, so you're given 2 numbers. No. 1 over 4. Right, so 1/4 to 4. 1/4 and 4 make 1. 4 and 1 make 4. 1 and 4 make 4. 4 and 4 make 16. 6, 4. Yeah, okay. So it's 1/4. Several students are seated in a large circle of the table. They pass out 100 candies each, and they pass it back to the next person. If Chris takes the first and last piece, it could be, right? Okay, well, let's think about this, right? If we have 10 people, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Chris gets the first one, second, third, 4, 5, 6, 7, 8, 9. Oh, 10. So he gets the 11th one. So he gets every 10, but you start at 1. So he gets the first, he gets the 11th, then he gets the 21st, so then he'll get the 101st. But there's 100 pieces of candy, so it can't be 10. 11, he'll get every 12th, he'll get every 11th one starting with 1. So he'll go 1, 12, 23, right? So 11x plus 1, which just so happens, if you plug in x equals 9, then you get 100. So the answer has to be 11. I mean, we could write it out, but there's no point unless we have 20 minutes. I still have to do problem 12. The graph relates the distance traveled in miles to the time elapsed in hours by an experimental airplane. During which hour was the average speed of this airplane the largest? Isn't it just the last? Is there something I'm missing here? It's an old competition. Maybe they didn't teach this, but you know, we draw this thing, right? The average speed of the plane needed to be largest. Where? Average speed, right? So he went, what? How much is this? Distance traveled in miles. No. Okay. So we need to find the place where the largest incline happened. Right? Because this is the total distance traveled. They didn't write that. But it is. Is it? Yeah, because it's one trip. And it's unrealistic. I mean, so that's the total distance traveled, right? Where's the largest incline? Let me zoom in, please. Nope, no, what the heck? Oh god. What happened? Whoa. Like barely. Let's turn off touch. Maybe that'll help. No, okay. Alright, so here we are. Bam. That's a lot of incline, right? Let's say that's around 450. At incline 450 there. But oh, skabdoosh. That's about 900, I guess. But there's nowhere else just that incline happen as fast. So, I mean, it looks as though the second one has a higher incline. That's a really bad problem because it hasn't labeled. But, what can you do? Let me zoom out now. Oh, no. Okay. Alright. Oh, once again, I'm using AOPS. Please check it out. Okay. Oh, is someone typing chat? No, I get no viewers. 3 triangles and a star will bounce 9 circles. 1 triangle will bounce a star and a circle. How many circles will bounce 2 things in this balance? Okay. Okay. Cool it, man. Okay. So we want to find how much is 2 of those, right? Oh no. Okay, so we know that the diamond is equal to triangle minus circle. Right? Because if you subtract circle from both sides so on this one, right? And that makes it so much easier. Yeah, so we've isolated that. Diamond is equal to the triangle minus the circle. So that's another triangle. So 4t minus O equals 9O. 4t minus O equals 9O. 4t equals 10O. 2t equals 5O, right? But then no, we want it in terms of triangles. So that's circle plus diamond, right? Oh, that makes it so much easier, right? So we want the triangle in terms of diamond because we're trying to find 2 diamonds, right? So triangle is circle plus diamond. So 4 diamond plus 3 circle equals 6 circle. So if we subtract 3, 4 diamond equals 3 circle. What? No, sorry, 6 circle. But then we want 2 diamonds. We have 4 diamonds, so we divide by 2. 2 diamonds equals 3 circles. Oh, that's 2 diamonds equals 3 circles. Does that make sense? So I know that triangle is equal to diamond plus circle, so I plug that in. So we have then 1, 2, 3, 4 diamonds, and then 1, 2, 3 circles. So 4 diamonds plus 3 circles equals 6 circles. I mean, 9 circles, right? Because there's 9 of these. And I subtract 3 circles. 4 diamonds equals 6 circles. I want 2 diamonds, so I divide by 2 to get 3 circles. Good problem, good problem. Oh no. What? Wait, I'm really confused. Flips and returns. Okay, how many different patterns can be made by shading exactly 2 of these 9 squares? Oh god. Huh? 10 minute. 10 minute. नहीं, मैथ कर रहा हूँ. Math. Okay. Let's draw our square, right? So 1, 2, right? 3, 4. So we can have, 2 next to each other, as so. Right, and then that covers all the possible rotations and stuff. You can also have 1 in the corner and 1 in the middle. You can have 1 in the edge and 1 in the middle. Right, so that's 3, and then you can have 1 here and 1 here. That gets us 4. I don't like this. You can have 1 here and 1 here. That gets us to 5. 1 here and 1 here. That gets us to 6. I believe that's all of them. How about 1 here and 1 here? That's 7, and 1 here and What? We're just gonna go 8 because it makes sense. Oh no, 1 here and 1 here. Right, 8. And then the other ones, I don't believe there's any more because we'd have to find 4 more, and that's highly unlikely. So, now we have 12 left. Let's just write it all out, right? Okay, so there's a lot of space here. We only need to find the 17th one, right? So 7, 5, and we're going from the top down. '24th, 23rd, 22nd, 21st, 20th, 19th, 18th, 17th. 5724 is our answer. I believe we have completed this. Now it's time to check our answers, but first let me write down all the answers that we've gotten. E, B, C, B, E. That's pretty simple. E, B, C, B, E. Oh god. They've all moved down, haven't they? Oh my god, okay, where? Why? Okay. Anyways. E, B. Oh my god, you gotta be kidding. Okay, C, B, E. This one was D. So D, A. Oh god, I don't like this. D, A, C, B. D, A, C, B. C, B. Well, that's convenient. A, B, B, B. A, B, B, B. A, B, B, B. I don't like this. I feel like I failed. C and then C and then C. C and C. Of course, I checked my answers. However, I'm not going to. Savage. Let's find the answer key. Oh god, I'm really scared actually for this one. Okay, C, A, E, E, A, D, C, D. C, A, E, E, B, D, C, D. Oh god. I must have... Oh no. Wait, isn't that the one that I transversed? Okay. Well, those two are wrong anyways. Maybe I just messed up. C, A, E, E, B, D, C, D. I got the C, D right. Wait. C, A, E, E, A, D, C, D. So I only missed one of those. Okay. That's D, A, E, B, C. D, C, D. D, A, E, B, C. Wow. B, E, D, A, C, B. B, E, D, A, C, B. Wow. A, B, 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 C, C. A, B, 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 C, C. Wow. So we only missed this one. That's kind of sad. That's even more sad. What was 5? I must have rushed through it or something. 5, 5. Oh, what? Okay, let's look at solution. No way, man. B. Ah. Okay, clearly, yes, obviously. Since the function is strictly increasing, yes. From which it follows that A is much too small. Oh, right, because... yeah, that makes sense. So basically, what it's saying here... Did I mess that up? Yeah, it's quite close to 1/2. That is just below 1/2, which is 0.125. Right. Okay. Well, good times. We've missed one somehow. I'm kind of humiliated. that was pretty sad. But, check out AOPS. I'll give a little walkthrough in the time that we have left. 7 minutes? Okay. Let me sign in. It's invalid again. Okay. So here we are. There's many things. Let's start on the resources page, shall we? Let's start with Alchemist. What's this, you might say? Wow, I know. You can read this, pause it, whatever. Let's play. I mean, oh my god. Yeah, please, no. Okay, so here's the pre-algebra section. There's one more green. How did that happen? Okay. You have arithmetic, you have squares, positive exponents, all this stuff. Grape is going to be teaching it. You can practice it so much here. Look at this. Look at all this stuff. This is just in the pre-algebra section. If you're, too smart for this, you got the algebra section. I know. So much stuff. You got everything in quadratics, everything in functions, domain and range, inverses, polynomial multiplication, interest, logs, radical expressions, absolute value, floor and ceiling, arithmetic sequences and series, geometric sequences and series, and clever algebraic manipulations. And you've got up here, you've got graphing stuff, you've got factoring, you've got midpoint of a segment, all that. Let's check out number theory. Multiples, divisors, primes, all this stuff in number theory. That is incredible. That's so good. You got modular arithmetic, you got base converting, you got base powers, you've got LCM, GCD, prime, factoring. Awesome stuff. Awesome. Counting probability, counting numbers, Venn diagrams. It goes all the way. Complementary, constructive, counting with restrictions, distinguishability. So much stuff. Geometry, you get the gist. And if you're really smart, you got intermediate algebra and pre-calc. So yeah, and then you've got all this stuff. You can change the settings if you would like. How much did that? Oh my god. Okay. Yeah, pretty awesome. Then you've got all these handy dandy videos about it's so much stuff that teaches you everything. You've got all these math counts minis taught by your boy Richard Russick, AOPS founder, awesome guy. For the win, super fun game. So it's basically like a countdown style, like you first to buzz wins. I'm not gonna join a game, but let's see if I can spectate. Can I spectate? Alright, so let's see. Okay, yeah, never mind. But it's a speed game. Math Counts Trainer. It basically takes you up from the school level to the chapter level and gives you tons of problems. Oh, I'm on the national. I didn't even know. Okay. LaTeX texture. MIT Primes is like way advanced. LaTeX is for typing LaTeX. Got the AOPS wiki where you can have all the AMC problems from the AMC 8/AJHSME up to the USAMO and IMO. And then proofs without words, that's just proofs. Pretty cool stuff. Math competition resources. There's lots more math competitions. What else? Oh man. AOPS news. These are just random games. You've got the forums where you can talk about math competitions and math with a huge community. Pretty epic. Look at this. These are the number of users that are online. Oh my god, there's so many. This is insane. Okay. Anyways, guys. You got your community. Look, you have middle school, high school, contest, Olympiad, site support, college math. You've got an online school with you know, there's let's look at the course catalog real quick. 1:51, right? Okay. Introductory math, you've got all this stuff. Intermediate math and advanced. You can take calculus, group theory, you can take WOOT courses, contest preparation. There's tons of contest preparation stuff. Computer science and programming. So yeah, that's AOPS, of course. As you can see, no ads. I didn't have to pay anything. There's also a huge library. How can we find the library? Bookstore, of course. AOPS curriculum. So there's all these books from, oh god, AOPS, pre-algebra, algebra, accounting, yeah, all this, intermediate, all this stuff, which is useful for the classes. You've also got AOPS Volume 1 and Volume 2, which are for preparation. Then you've also got this book, Competition Math for Middle School. Really good book. Tons and tons. Beast Academy for if you're a newcomer, you know, you've got comic books for 2nd through 5th. You've got yeah, pretty cool. Yeah. I'm not like sponsoring them or anything, but they're really good. That just about does it. How do I end this stream? Where do I go? Alright, thank you for the stream abilities. Goodbye, and goodbye.